Hey everyone, welcome back. This is Maddie. From this video, we'll be starting with a new playlist where we will be learning writing algorithms and analyzing a space and time complexity of the same. In this video, we'll be seeing the introduction part of algorithms. You may be thinking of what is this algorithm, how it is different from program, right? Let's discuss that now. An algorithm is a step-by-step procedure for solving a computational problem, whereas program is a step-by-step process to solve a problem. Let me just write down that here. Now, what is the difference between these two things? Let us take an example and discuss the difference. Let's take you're building a software which will be having many phases, right? Let's generalize all the phases into two main stages. The first stage is designing stage and the second stage is implementation stage. While designing a system, we can't do trial and error methods by implementing a problem in design phase, right? That's when algorithm comes into picture, where we write the step-by-step process to solve a problem without actual syntax. Whereas programming stage is nothing but a implementation part of designed system, which is nothing but an algorithm. Now let's answer two more questions. The first one is, what languages should a algorithm and program use? Algorithm can be written in English language like para or mathematical notations, but the recommended option is using mathematical notations. Whereas program can be written in many languages, as we all know. This can be written either in Java, C, C++, Python, and many other languages. And the second question is, what should be done after writing algorithm and program? Once writing an algorithm is completed, we need to analyze it by space and time complexity for best, worst, and average cases. Don't worry about best, worst, and average cases. We'll be covering all those things in this playlist itself. Once the programming is done, we should test it by passing different input for the written program, just to make sure nothing fails. We have one more important concept. Let us look into that. Priori analysis and posteriori testing. Now let us see what are these and what are all the tasks that are taken care in these phases. As we now just discussed, priori analysis is done during algorithm writing phase. Done during algorithm writing phase. Whereas posteriori testing is done on the program after implementing the written algorithm. Done on the program after implementing an algorithm. The algorithm can be written in any languages and it is language independent. Whereas program should be written in specific languages, so it is language dependent. Why? Because we can't write some part of algorithm in Python language and the other part of algorithm in Java language, right? Priori analysis is done using space and time complexity of an algorithm, which we will be doing the same thing for all the algorithm in this playlist. whereas posteriori testing is done based on how much time a program is taking and the memory it consumes. I hope the introduction part of algorithm and the difference between algorithm and program is now clear. Let us look into some of the characteristics of an algorithm. The first one is input. Every algorithm should be capable of taking 0 or more input data. And the second one is output. An algorithm must generate at least one output. If we are taking an input, then it must generate at least one output. Now you may be thinking of a void functions which returns nothing, right? Answer to that is void functions are not the entire algorithm, they are some part of algorithm. Meaning, even though they are void functions which will be returning nothing, they will be doing something on the process, updating some values or adding some values. Those kind of things will be taken care by void functions. They will do at least something on the process. The third characteristic is definiteness. Every statement in an algorithm should be an ambitious and it should have a single exact meaning. Unsolvable statements should not be written in an algorithm. Every statement that is written in an algorithm should be clear and should have single meaning. If we human cannot solve a problem, then computers cannot solve the same. That's the reason whatever the statement you write in an algorithm should be clear and should have single meaning. The fourth one is finiteness. What does this mean? Every algorithm should have a finite number of steps. Like the functions, algorithm should have some steps and then do something and at the end return at some point. The fifth characteristic is effectiveness. Effectiveness meaning every statement in an algorithm should serve same purpose. There should not be some unnecessary statement which does not solve our goal or our problem. I hope this video was helpful. In the next upcoming video, we'll be seeing how to write and analyze an algorithm. Thank you all for watching. See you in the next one.